You are welcome to tutorial 4. This tutorial 4 will have the topic as written on the board, measurement. Measurement is very important because whatever we want to build or construct, we take measurement in order to construct to a particular size. That is why builders, tailor, carpenters, they need the idea of measurement. Even in the laboratory like this, we need the idea of measurement, and that is why I want to deal with measurement. In order to measure, you need some instruments to do that. And I would like to start from the vernier calipers. Vernier calipers. Vernier calipers are measuring instruments that measures in centimeter. You must take note of that, centimeter. They measure in centimeters. You can use vernier calipers to measure the internal or external diameter of a cylinder or cylindrical shaped object. Now, how do we use this to measure? You need to know two types of scale on the vernier calipers. This is the vernier calipers. Two types of scale. We'll have these scales here. We call them the main scales. The main scales. Then we'll have another scale in division. If you check carefully on this point here, you see vernier scale. But vernier scales are in division. You need to convert them to centimeters before you add to the value of the main scale. If you are given question to solve under this vernier caliper, at times the question comes in this form. We have question in this form. They tell you what is the actual reading of the vernier calipers as shown in the diagram. Now, what we are going to do is to first of all get the main scale reading. In this case, this is the main scale reading. And this one's beneath here, they are the vernier scale reading. So, from here you see we have 3 here. But before 3, we have 2, which is not shown in this diagram. If you check this point from 3 to 4, you discover that you have 10 small lines, giving you 0.1 for each of these lines. So the main scale here will be 2.9, because after 2.9 you have 3. 2.9. 2.9 centimeters plus. Now we want to get the vernier scale. To get the vernier scale, you count these ones beneath here. You continue to count until you meet any of these vernier scale line that coincide with the main scale line. Now you check this. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm stopping here because this number 10 line coincide with the main scale. And then the main scale, like I said earlier, they are in division. In order to convert it to centimeter, you divide by 100. So I have 10 over 100. Now is in centimeters, which means I have 2.9 centimeters plus 0.1 centimeters, giving us a value of 3.00. You can put it 2 decimal, 3.00 centimeters. So the reading as indicated on this vernier caliper is 3.00 centimeters. Now, the number 2 instrument we are going to deal with is the micrometer screw gauge. Micrometer screw gauge. This is the micrometer screw gauge. This is the micrometer screw gauge. You check it also. This one is calibrated in millimeters. Remember, vernier scale in centimeter, micrometer screw gauge in millimeters. You check it also, we'll have 2 scales here. These ones we have here, they are the main scale. Check it. They are the main scale. Then, if you check on top of this, sliding on the main scale, we'll have other scales there also. Call these scales vernier scale. This one is also in division. But if they give you question, you see the question like one of the past questions I have here, you see, at times they draw it complete, and at times they draw it halfway, such as what I want to draw on the board now. Now, we are on the micrometer. Micrometer screw gauge. You have a diagram like this. You have 10. Here you have 15. Now, we have other scales. Here, they call it half millimeter scale. You can see it down here. Now we'll have it like this. If they ask us to calculate the reading of the micrometer screw gauge as shown on the board, it is simple. We first of all get the main scale. Now what is the main scale? Remember, I said these ones down here, they are half millimeter scale. I have 15 here, 15 and a half, 16, 16 and a half. So I have 16.5 as my main scale. 16.5, can put 0 millimeter plus. Now the division. The division, you need to count this one. This is the vernier scale. Count from this point until anyone that coincides with this line. That's where you stop. So we'll have 10 here. 10, 11, 12, 13, 14. So I have 14. Now I have 14 divided by 100 because it's in division. I need to convert it to millimeter. Divide by 100. So I have 16.50 millimeter plus 0.14 millimeter. And when I do this addition, what do I have? 0 plus 16, I have 16.5 plus 1. I have 6. 0 plus 4, I have 4 millimeters. So the reading of this micrometer screw gauge is 16.64 millimeter. That is the reading. That is the reading for the micrometer screw gauge. That is the reading. Now, let's quickly check volume, because volume can also be measured. Let's quickly check volume. For volume, it could be regular or irregular. Regular or irregular. Now, we'll have this rectangular block, rectangular in shape. If we are asked to get the volume, it's simple. We just use ruler. We measure the length, the breadth, and the height. We measure the length, we measure the breadth, and then we measure the height. We multiply these three sides, we get the volume. If it's a cube, which means all sides are equal, you just measure one of the sides, you multiply it by itself 3 times. That's L cube, give you the volume. Now, for a spherical object, such as this, we can measure the volume by finding the radius. Now, in case we don't know this micrometer screw gauge, we can use it to find the diameter of a ball bearing. You just put it there, fix, do the measurement, and then the normal calculation. You can use it to find the diameter of ball bearing. You can even use it to find thickness of paper. The thickness of paper can be measured using micrometer screw gauge. Now, once you find the diameter, you divide by 2, you get the radius. You just use the formula for volume of a sphere, which is 4/3 pi r cube. You get the volume of a sphere. Talking about regular measurement. Now, for irregular measurement, we have some objects that their shape is irregular. For example, a stone like this. They ask you to find the volume of this stone. How do you get the volume? It's simple. You use one principle we call Archimedes principle to get the volume of this stone. Now, what you do is that you pour water into a beaker and then you try to check what is the level of this water in the beaker. I check it before now. It is 4 plus 50 mil, which is 400 plus 50 mil, which is 450 mil. Now you know the initial level of the water. You just immerse this completely and gently so that you don't spill the water. You now try to check. If you check carefully, you discover that you have 500 mil. Now, to get the volume, you subtract 450 mil from 500 mil. The result is 50 mil. So the stone immersed completely in this water, the volume is 50 mil. Is 50 mil. Now, we can also measure the weight of an object. We can measure the weight of an object. The best instrument to do that is called the spring balance. The spring balance can do that measurement for you. Now, we have some set of mass here. Let's use it to measure the weight of this object, and then we'll see what is the actual weight of this object. But in the first place, you check what is the reading, the initial reading of that spring balance. You see it's reading 0. Now, we attach to see the new length. Now, check the new length. It's giving you 2 Newton. It's giving you 2 Newton. Let's do that confirmation. Each of this mass is 50 gram. Each of this mass is 50 gram. 50 gram. And we'll have 4 of them here. We'll have 4 of them. We'll have 4 of them here. Now, let's see. If we'll have 4 of them and 1 is 50 gram, it then means altogether we'll have 200 gram. 200 gram. Let's convert 200 gram to Newton and let's see what will be the answer to that. Remember, it's weight we're measuring. We're talking about the weight of an object. We'll have 200 gram. In order to convert this to Newton, what do? You divide by 1000 in order to convert it to kilogram. Then, if you have it in kilogram, you want to convert it to weight. That is in Newton, you multiply by 10. As you do this multiplication, it's no longer in gram, but in Newton. What happened? This goes with this goes with this goes with this. What I have left is 2 Newton, giving us the confirmation of what we just measured using the spring balance. Now, we can also measure the mass of an object, because a lot of us confuse mass and weight of an object. Some people say it's the same thing. It is not the same thing. We use chemical balance to measure the mass of an object. For your own assignment, I would like you to list 5 differences between weight and mass. 5 differences. We'll have 5 good differences between weight and mass. Give me their difference. Thank you very much as we move straight forward to tutorial 5.